You are listening to The Vocal Technologist. Spoken tech for your ears.
It just feels like every time we sit down to talk, the ground has shifted again. I mean, the amount of information coming out of software engineering right now.
It's a fire hose.
It is,
Yeah.
especially around AI, architecture, front-end stuff. We've got agents literally writing production code, entire backends getting rewritten in a weekend.
And that's the thing, isn't it? The pace it's incredible. And that means learning, like really targeted learning, isn't a nice to have anymore. It's the only way to keep up.
Absolutely. So for you listening, that's our whole mission today. We want to give you that strategic shortcut. We're going to focus on three, I think, really critical areas.
Okay.
First, the whole AI explosion, the good, the bad, the complicated. Second, some really high-stakes architectural choices that affect performance and money. And finally, we'll get into the weeds on the front end with state and some surprising security lessons.
Sounds good. Let's start with AI, because the intelligence being built into our tools is it's evolving past just being a simple helper.
Oh, way beyond. I think the perfect example is this idea of an answer engine, like what Perplexity has built. It's not just another LLM.
No, it's the architecture underneath that's so interesting. It's a full Retrieval-Augmented Generation pipeline. A RAG pipeline.
Right. Which, for anyone who doesn't know, means it's not just making stuff up from old data. It's actively searching the web right now.
Exactly. It's pulling verified snippets and then building a cited answer from fresh context.
The scale of that is just mind-boggling. I saw they're using Vespa AI to index over 200 billion URLs.
And it's not just about the index. The real magic is in how they route the queries. They have their own in-house models. They call them sonar models.
Right.
But they'll also pass a complex query off to something like GPT or Claude if it needs that extra horsepower. That kind of multi-model orchestration is becoming the new standard.
And we're seeing this move from just answering questions to, well, actually writing code in production.
Look at Spotify. They have a background coding agent it's generated and merged over 1,500 pull requests.
And that's the key, right? It's not writing brand new features. It's doing maintenance. The tedious stuff.
All the dependency updates, the migrations. It's cut down their manual work by 60 to 90% in some cases. It's not replacing the engineer. It's just getting rid of the grunt work.
But all that speed, it has a dark side, a really significant side effect, which is just this overload of information that pretends to be helpful.
Yes, the AI code review tools. Developers are drowning.
I saw a stat that said up to 80% of the comments these things generate can be totally irrelevant, just background chatter.
So the really critical stuff, the important warnings, they just get lost in the flood.
So you need to be looking at the tool signal ratio, right? The number of actually important comments versus the total.
It has to be over 60%. It really does. If it's lower than that, the tool is actually making you less efficient. It's a drag on the whole organization.
And this all comes back to trust, which leads to the interview crisis.
Oh, it's completely broken the technical screen.
Because candidates can just cheat. They can get a perfect score without actually being able to reason through the problem in real time.
And so companies are swinging back. They're going back to in-person interviews where they can actually see how you think, how you collaborate. They have to assess the human, not the AI's output.
So with all this automation, what is the one thing, the irreplaceable human part of being a developer?
It's the learning loop. LLMs are great for brainstorming, for getting rid of boilerplate, but they cannot replace the experience of building something yourself.
You mean failing?
Yes.
Yeah.
Observing, experimenting, and failing. That's how you build real expertise. You have to internalize that process, and AI can't do that for you.
That is the perfect transition to architecture.
Yeah.
Because if you build all this AI speed on a shaky foundation...
You're just going to collapse faster.
Exactly. And we're seeing these big technical choices paying off in huge ways.
Huge ways, in both performance and, actual dollars.
Let's talk about that company, Scald. They had a Python and Django backend, and they just hit a complete wall trying to do async calls with LLMs.
Yeah, Python's async story can be, let's say, unintuitive compared to something like Node.js.
So they did something crazy. They migrated the entire backend to Node in 3 days.
Okay, hold on. A 3-day migration. I mean, that's amazing, but was that a strategic win or just a panic-fueled sprint that could have gone horribly wrong?
I think the speed just shows how much pain they were in. The Python setup was the technical debt in that context, and the result was a 3-fold increase in throughput?
Roughly, yeah.
Yeah.
And a much cleaner code base.
Yeah.
So it paid off. But that was targeting throughput. For cost, You look at a rewrite.
You look at TikTok.
Exactly. They took these super critical CPU-heavy API endpoints that were written in Go.
And they surgically rewrote them in Rust. This wasn't a full rewrite of everything.
No, just the most expensive parts of the code.
And the result was double the performance, lower latency, and they're projected to save almost $300,000 a year on their cloud bill.
Which proves that using the right tool for the job, especially the most expensive job, pays for itself almost immediately.
And speaking of expensive, we need to talk about what we mean by debt. It's not just technical anymore.
We have to start thinking in terms of architectural debt.
So you mean it goes beyond just messy code. It's in the org chart itself.
Precisely. It's in the business layers. Think about documentation. Who owns what system? It's in the strategy layer. Leadership can't plan for the future because they don't even know what their current systems are capable of. It infects everything.
So how do you fix that? We all do retrospectives, and they almost always fail.
They fail because the action items are useless. Everyone leaves the room saying, we'll investigate this problem.
Sure.
Investigating isn't a solution.
So what's the actual fix, the antidote?
You borrow a concept from the Toyota production system. You create a rotating role, a fixer.
A fixer. I like that.
This person's job, their only job, is to implement a permanent solution to whatever problem was identified. Not a patch, a real fix. And it has to be done before the next retrospective.
That forces ownership. It stops you from just talking about the same fire every single meeting.
Exactly. It changes the culture.
That's powerful stuff. Okay, let's pivot. Let's go to the part everyone sees, the front end, which has its own set of really interesting challenges.
It really does. And if we're talking about structure and boundaries, you know what the best tool on the front end is? The URL.
It's so underrated. People just see it as an address, but you need to treat it as a first-class state container.
Yes, because you get so much for free.
Yeah.
Shareability is built in. Bookmarking just works. The browser's back button, it just works.
You just have to be smart about it. You use push state when you're making a big change, but replace state for the small stuff so you don't clog up the user's history.
It just makes for a more predictable app.
Yeah.
But speaking of what's visible, we should talk about what developers sometimes make visible by accident.
Oh, you have to be talking about the Apple App Store leak.
I am. Apple accidentally shipped their entire front-end source code.
And it was because they forgot one tiny thing.
They forgot to disable source maps in production.
Which is such a good lesson. These little debugging tools can become massive security holes. So for anyone listening, what is a source map actually doing?
Well, your production code is all minified, right? It's an unreadable mess. The source map is the translator. It contains all this encoded data that maps a position in that messy file back to the original source file and line number.
So it's essential for debugging.
Essential.
Yeah.
But if you ship it to the public, you've basically just handed them your source code on a silver platter.
The cost of a small mistake is always high. All right, let's do some rapid-fire front-end stuff. I saw a tool called Uniwind recently.
Oh yeah, that's solving a huge pain point for React Native developers. It gives you fast native bindings for Tailwind CSS.
Which was always a headache in that world, trying to get styling right.
This gives you one unified, performant way to do it. And another one, if you're working with audio, is wavesurfer.js.
That's the library for creating those cool interactive audio waveforms, right? You see them everywhere.
It's the standard. Super useful. Okay, finally, we can't talk about JavaScript without talking about its weirdest quirk.
Oh, I know this one. Nan is not equal to Nan.
Not a number does not equal. Not a number.
It feels like a bug. It sounds completely broken, but it's intentional, isn't it?
It's mandated by the IE 754 floating point standard. And the reason is actually for robustness. Think about it. If an invalid operation, like dividing 0 by 0, created a value that equaled itself, it might crash your whole program.
Oh.
But by making Nan not equal to itself, the program can keep running. You can catch the error later without the whole thing falling over. It's absurdity for the sake of stability.
What a trip. We've gone from AI agents that give us this incredible speed to making architectural choices that can save a company hundreds of thousands of dollars, all the way down to why Nan is so weirdly robust. Knowing these specifics is what makes you a better strategist.
It's about connecting the dots. Seeing how our RAG pipeline connects to a Rust rewrite, which connects to fixing your team's retrospectives. That's the whole game.
Yeah. I want to leave you with one last thought, though. We've talked all about these objective technical decisions, but we almost never admit how emotional they are. There's neuroscience research that shows our choice of programming language is often tied to our identity. It's not always rational.
And when someone challenges that belief,
Yeah.
your favorite language, your favorite stack, your brain's threat responses actually light up. It's like tech tribalism.
And that tribalism has real consequences. I read about one case where a CTO's emotional attachment to Perl, when it was the completely wrong tool for the job, ended up bankrupting the entire company.
Wow.
That's the non-technical stake in our very technical world. It makes you realize that being a great engineer means you also have to be a vocal technologist, someone who can champion clarity and strategy over just, liking something.
That's a powerful reminder.
Thanks for jumping in with us today.
Anytime. Until the next one.
Spoken Tech for your ears.